Well, thank you, Dmitry, and thank you to ITMO for the invitation to be here. I've been here once before, and Dmitry tells me that was before he was born. So that means either he is very young, or I am very old, or both is true. Actually, both is true. Yes, I was here in the 1970s, believe it or not. But the metro was much the same. Great experience. Just there's more of it now. And I forget nearly everything else. I'll tell you a bit more about myself. And I will also say to you straight away, I appreciate that you've had somebody from Netherlands, somebody from Italy but who lives in the Netherlands, and somebody from Germany, all speaking English. And now you have somebody from Ireland speaking English, and it is my first language. I hope I don't make the mistake of many people for whom English is their first language, that they assume that if they speak quicker and faster that you'll understand everything, or louder even. I'm very used to speaking with audiences who are not in their native language, but please, please, please stop me if it's not clear. Stop me if it's also not clear at the intellectual level as well as the linguistic. I really would appreciate that. This is, after all, the week for participation, okay? Okay, and that's why I'm sitting down. No, I don't like those things, and I don't like to use them. So this is not a lecture, it's a talk, and it's a discussion, I hope. And I really would appreciate, and Dmitry, please too, you know, if you would think that some question it needs a bit more explanation or some clarification or investigation, please say so, and we'll spend time. If I don't complete my slides, that's not a problem. I'm used to that. I always have more than I need. So I was a journalist for full-time for 20 years, from the early 1970s, and at a certain point considered I had done what I wanted to do in journalism, and I had started teaching part-time journalism students at the same time as I had begun to specialize in reporting science and technology. Okay, so late 1980s, early 1990s. And I joined the university in 1992, saying then at interview, I remember, very naively, that I had this ambition that I would do something in this area, which I didn't even know what it was called. Whether it was going to be science journalism or science writing or something. And we had this conversation earlier, Dmitry and I. The term science communication barely existed at that time as a concept to describe all the things that it now describes. And as year goes on to year, it describes more and more because there's more and more different kinds of activities going on. But indeed, my ambition wasn't entirely out of place. The year after I joined the university, I was able to organize a small conference on questions in science and communication. And the year after that, we began work on our masters, which started in 1996. So this time, 20 years ago, almost precisely, I think, I was in a room with external experts present to whom I had to present this case for a master's in science communication. At the time, there might have been 5 or 6 programs like that. 1 or 2 in France, 1 or 2 in Spain, 1 in Germany, at least 1 in Italy, but not many more than that. And now the Netherlands has 4 or 5. At that time it didn't. Yeah. It's now a big center for these things. So that's part of my story. And about the same time then I started, or fairly soon after that, I started researching and writing and reflecting and doing some theory in the area of science communication. And that's mostly what I do now. I'm retired from the university. As I told you, I'm very old. And I do some training with scientists, short courses, JCOM masterclasses was the last one that I did. JCOM masterclasses take place in Trieste in northeast Italy. And they run over 5 days, and they bring together researchers and research administrators and managers and so on from many countries, and we do 5 days on communication with them. I am also very active in the international community, so that's the reference there on the screen to PCST, Public Communication of Science and Technology, which has now become a bit out of date, and we have to think about whether we keep that. So I've now added this part to the title, the Global Network for Science Communication. It is global, really global. And I'm the president of that network, so I will be effectively the chair of the next conference, which takes place next April. It'd be lovely to see some of you there if you're continuing this interest. It's a great place to meet other people like yourselves who are even just beginning to explore this area. And Dmitry says he'll be there, for sure. It's at the end of April. Anyway, this is a great week to be thinking about public participation in science. You know why? Because this is what was going on the streets of Paris in one case, New York in another case, and a small city in the southwest of India in another case. Yeah. And this is a kind of public participation in science. The shoes in Paris was very poignant. Did you see this on television at all? As you know, Paris is going through a big trauma after the events of the 13th of November. And the government which was hosting the climate change conference, was also dealing with the situation after the 13th of November and the murders, 130 in the nightclub and in the cafes and so on that you know about. And they had, as part of dealing with that emergency, put a ban on any large gatherings in the streets. Yeah? I don't remember what a large gathering is, but above a certain few hundred. So one way for people to signify that they were there was to put shoes down in the Place de la République. And the slogan they were chanting was very powerful. It was "Nous sommes là." We are there. We are there. Yeah? We're making our voices heard even though we cannot assemble. And so what they did was they did not go onto the streets in big numbers. They formed a chain, holding hand to hand, right up the boulevard, which goes from the Place de la République for about 2 kilometers along the pavement. So no law was broken, but they were saying, we're here in numbers. And why do I think that's participation in science? Well, because climate change and the climate change policies of governments around the world are significantly influenced by science. Climate change is a scientific discovery itself. Yeah? Or we really ought to say climate change, accelerated climate change, perhaps. Because climate change is a thing that's already existed for as long as the planet has existed. And it really annoys me when I hear people saying that these protests were against climate change. That's kind of like being against the moon, or something like that. Of course they're not. They're against climate chaos, is one of the terms that's used. And in the case of the in the case of New York, you'll see the number 350. Do you know what that refers to? 350? The campaign is called 350.org, yeah? And the target is to reduce the concentration of carbon dioxide in the atmosphere from 400 parts per million to 350 parts per million. Okay? So what's that? A reduction of 12%. Sometime. I don't remember what exactly the time scale is. But that's citizens, many of them, by the way, who are also scientists as citizens, setting themselves a policy, a political target that's defined in scientific terms, that requires scientific measurements, even using the abbreviation ppm. Now, if you walked into a cafe here and started talking to people about 400 ppm, okay, whatever the Russian equivalent is, I assume, people would not know immediately what that means. If you explained it parts per million, maybe they would. But they would wonder, how do you measure that? So people are dealing in a public way with scientific terms, scientific issues, scientific disagreement, interpreting science, even criticizing science. And it's happening across the globe on one day, including in India, where you see a reference to individuals who are active in citizen organizations, but possibly some of them have also formal academic or scientific qualifications. So, this is a form of participation. Agreed? Yeah? It may be, you know, that they're not actually talking scientists to public directly, in this case. In these campaigns, they will be doing so. I was asked this evening by email, would I please write a letter to the national broadcaster in Ireland to protest that a scientist who is a meteorologist called Ray Bates will be interviewed on the main current affairs program tomorrow night as part of their reporting on the Paris conference. And I was being asked to write a letter to protest because he is, in the words of the email sent to me, a climate denier. That's also like being against the moon. Now, there's no such thing that makes any sense as a climate denier. I deny the climate. It doesn't make any sense, any more than really a climate change denier. But you know the terminology, yeah? He is a meteorologist who has published papers on changes in climate. He was formerly advising the government some years ago on the current state of knowledge on changes in the climate. However, he does not draw from the information that's available and the data that he has available. He does not draw all the same political conclusions as the campaigners on the street draw. So now he becomes a denier. So I have written an email just before I came out to here to say, no, I will not write that letter. If I thought that he was, and my phrase was, flying in the face of all the science. Do you understand the phrase, flying in the face of? You know, poking his eyes, poking out the eyes of all the science, I would say possibly I might have written a protest letter saying he's not a suitable candidate to be part of this discussion. But that's not the case, yeah. So these arguments also get very intense, as you know, and very polarized also. But that's, democracy is a very messy business. And that's why we love it. But there's other ways we could interpret all of that as well. So, the publics then face science either directly or indirectly in many different ways, as in different roles. I think you took a copy, did you take a copy of the presentation? Do you have a copy of the presentation? Yeah, okay, but you have a copy on the computer here, Dimitri, so if you want to share this, that's fine. You can save time writing. And these are just some of them. So in the case of climate change campaigners, they're facing science as activists or just as citizens who have a concern. Yeah? More typically, we think of science and public related through some kind of learning. And increasingly, some institutions, both in Britain and in the United States, use informal science learning rather than science communication. To be honest, I don't understand why they've made the change, and I don't particularly like what I think it means, because I think it puts the public for science in a dependent role as a learner. Now, we all have things to learn from each other, and every one of you has got knowledge that I haven't got, and I've got knowledge that none of you have. So we all learn from each other in that sense. But usually when we talk about science learning, we're talking about something that's sort of structured around a relationship between the scientist as teacher and the member of the public as pupil or student or something like that. Anyway, when you get your big science center in St. Petersburg, I'll be the first visitor. And I'll be interested to see whether the science center addresses me as a learner or as a citizen, or maybe both. But those are big decisions to be made. Informal science learning is often attached to science museums and science centers. But if you think of learners as questioners, you've changed the relationship a bit. And I'll be very disappointed if you haven't asked me a question within the next 2 minutes. So you've got 2 minutes to think of a question, okay? Somebody, right? Okay? And I might have to pick on one of you. And then we, the members of the general public, we face science also as consumers and users of products and services and medications and so on that have been that are based on, at some remove maybe, but indirectly or directly on scientific research. We face science also as spectators. We read about conferences and we hear about papers published and so on, and we admire at a distance, these things. Or we just had the anniversary of the publication by Einstein of the, is it the general theory of relativity or the theory of general relativity? But you know what I mean anyway. The theory of general relativity, isn't it? Special. General.
1905 was the special.
1915, though, he did another paper, which is the anniversary was general, I think.
Oh yes, that was the general.
Yeah, okay. 1905, he wasn't even a scientist. He was working in a patents office. 1915, he was established as a scientist. Anyway, but Einstein became something to look at and admire, and not, it helped. Well, actually, look at me. But it helped that he had lots of hair and he had in a flamboyant and extravagant way, and he became a figure known to members of the public who didn't have a clue what E means, or M, or C, never mind C squared, or what even E equals MC squared might mean, which is even more complicated. So we are spectators and an audience in some cases. And then also we're observers or bystanders in other cases where we're not really that much involved. But I could extend this list. And all of these we can think of in terms of participation, even though it might not be obvious that being an observer is a form of participation. However, in the discussion in science communication, and indeed in theories of democracy and culture, participation has come to mean something much more active than being a spectator or being an observer. And we'll come to that. But just going back a few steps. In 1985, so 30 years ago, a report was published by the Royal Society in London, which is the oldest scientific society in the world, at least representing, as it were, modern science, as distinct from ancient. science, the Royal Society published a report called The Public Understanding of Science. And it was a program for action to address a problem which the society saw existed, that the public, always singular at that time, had a poor or weak or low level of understanding of science. Okay? And so public understanding of science became a heading for a movement, a program, and for practices designed or intended to address that lack of knowledge or lack of understanding of science in the public. Fairly soon, however, after 1985, public understanding of science was turned, ironically, by some people observing what was going on, say, well, what about the scientists' understanding of the public? How good is that? And of course, the implicit answer in asking the question was actually the understanding of the public was very weak, very poor, very low level. Yeah? So the acronym and the relationship was turned around. But that report by the Royal Society stated scientific literacy is becoming an essential requirement for everyday life. Now, what's scientific literacy? 2 minutes have passed and I've had no questions, so I'm now asking you a question. How do you know whether somebody is scientifically literate or not?
Well, apparently in Europe they thought that a good way of learning whether a person is scientifically literate is asking questions like, do you believe that Earth rotates around the sun, or vice versa? But this is very dubious, right?
Have you had discussions about this at all?
We touched on this.
Okay. This was a very, I mean, in this phrase, yeah, there is a very big assumption. There are two very big assumptions. One is that we can define and measure scientific literacy, A, and B, that having measured it and having defined it and measured it, well, maybe that's two different things, anyway, having defined and measured it, we can then say that you have to have it, whatever it is, in order to survive in everyday life. Yeah. So, do you think of yourself as being scientifically literate? Yeah. Because you have a degree? No. Because you understand that the Earth does go around the sun? Okay. Okay. You get the first prize. Yeah. But hang on, no, the sun comes up in the east and then the sun goes over like that. Yeah, so clearly the sun is moving, isn't it? Anyway, I'm joking. Yeah, but the question is it facts? And one of the factual questions is, it's not actually a question. The way they ask is the Earth goes round the sun, true or false? Okay, and you'll answer false if you think the sun goes around the Earth, obviously. An electron is smaller than an atom, true or false? A child inherits its genetic traits from its father, true or false?
What about tomatoes?
The tomato one is the famous one. You do it, okay.
Well, it was like genetically modified tomatoes have genes while ordinary tomatoes don't.
Yeah, something like that. Okay, yeah. Anyway, as Dimitri has suggested, there's good reasons to question what the value of this is. But you can measure the population, you know, in terms of the number of questions they get right or not. Yeah. How important to everyday life is it to know whether an electron is smaller than an atom?
Not much.
Not much. Not very important. I think you could probably get through life as a very worthwhile individual without knowing the answer to that. Yeah? And to lots of those other things. Now, there's a great quote which I was going to use later, but I'll use it now, by somebody who was a pioneer in these studies, and I have a picture of him, I'll show it later on if I have time. John Durant. John Durant set up one of the very first Masters in Science Communication, Durant, in Imperial College in 1992. And he set up also the journal Public Understanding of Science, which now, 23 years later, has this bloody name around its neck. And it knows it's a problem to have this name, but why would you, it'd be stupid to change it just because something has gone, as it were, out of fashion. Yeah. John Durant said in a very good paper in 1994, so very soon after all of this kind of statement was being questioned. And John Durant said, he asked the question, what does the public need to know about science? Okay? And he said, the first level of knowledge may be to do with facts. So there are some bits of information that science has established about the natural world that it's important to have, okay? And then there is how science works. This is really important in the context of the climate science, climate change debates. Knowing how science works in terms of how findings are validated, theories are confirmed or denied or whatever. Yeah. And then he said, and there's a third level, how science really works. Implying that the notion of the scientific method, which you all, I'm sure, or have used that terminology, that idea, that the notion that there is a single scientific method that proceeds in this ordered way for everything that's done in science is completely nonsense. Just like democracy, science is also messy. And the negative results don't get reported. In fact, the professor sends you back to the lab to finish it until you get the positive results. Because the theory says that's how it will be. Yeah? Is that right? Am I saying something that you can recognize? Yeah. How science really works is a bit different from how science ideally works. Okay? So there are different kinds of literacy, if that's the right term at all. Yeah? But the scientific literacy of the 80s and the 70s was defined largely in terms of those factual questions. Then they added in questions about process, but never really questions that would allow you to get to how science really works. These surveys of literacy and then surveys of attitudes have gone on for a very, very long time in the United States and then for shorter times in lots of other countries, but certainly 30 years and more. And Martin Bauer, who's the first name there, who's a Swiss person living and working in London, he's one of the people who has written a lot about science attitude surveys. And he and his colleagues produced this paradigm of 3 different paradigms of science surveys. First phase being science literacy, as I just referred to it. The second phase being public understanding, where the focus was on that deficit, that lack of knowledge, but also on attitudes. And the third one is much more related to the themes of this week, is much more to do with participation. So where, for instance, you talk about relationships between public and experts and those changing relationships, and you talk about trust. It's very difficult to survey people on trust, but it can be done, and it is being done. And one of the incentives for people to participate in science-related questions and controversies and campaigns is that they trust or do not trust various people involved. A good example is the debates that developed a very high level of participation in some countries in North America and Western Europe in particular, but actually well into Asia and elsewhere. Also, the debates around genetically modified organisms and genetically modified, particularly genetically modified foods and genetically modified crops, okay? As the debate played out in Ireland in the late 1990s, very like other countries, the big issue really was trust issue. The people who were opposing genetically modified crops and foods did not trust what they were being told, and they had a very strong reason for not trusting what they were being told, because one big multinational corporation had a big interest in ensuring that genetically modified crops and foods were accepted. And somebody here over here is nodding. Do you know the name of the company? No? Monsanto. And Monsanto had a huge investment in GM seed, which they wanted to sell around the world for rice and various other cereals, but also for sweet potato and sorghum and potatoes in the case of Ireland. Yeah. And not surprisingly, citizen groups emerged saying, you guys are only in this for the profit. Why should we trust you when you say these are perfectly safe? Yeah? So that's kind of participation. And trust relationships have become much more interest to people researching this field. And the related idea of the crisis of confidence is referred to there. But if we just look at really basic kind of surveys, you may be familiar with the EB Eurobarometer. Yeah, have you had a chance to look at this? Yeah.
Yeah, Alex showed us.
What? Alex did. Okay. Well, what I won't spend too long on this, but what you, even by asking a relatively simple question across 28 countries, actually I think it's 29 because they've added in Croatia. Yeah. Even by, no, sorry, it's 28 including Croatia, sorry, 27 plus 1, because Croatia had not joined at that time now. Anyway, even by asking a relatively simple question across 28 countries, you see differences, and then that allows you to do interesting relationships between, you know, simple statistical findings and cultural contexts. Yeah? So this is very hard to read. But the question is, how informed do you feel about developments in science and technology? Now, there's a problem with the question, which you can immediately see, and that is it's asking people to say how they feel and how informed they feel, and you can guess that they're probably going to overstate their feeling of being informed, because they feel foolish saying, I'm not informed. Yeah? However, that's another question for another day. And the blue, dark blue and light, medium color blue, it means I feel informed. And the red means do not feel informed, okay? So you get this shape here from Denmark with a percentage 17 plus 48, 65% saying informed, to Romania, which is this one here, with 21% plus 4, 25. So 65% to 25%, yeah? And obviously the red and the blue are in inverse relationship, okay? So immediately you can ask questions about cultures of participation, as well as cultures of education, cultures of public discourse, and so on, yeah? And you can fairly quickly see, even if you can't recognize all of the names, if I give them to you, Denmark, Sweden, Luxembourg, United Kingdom, France, Finland, Malta, strange one, Ireland, Netherlands, Germany, Belgium, and there's the EU average, okay? So, if you take Malta out of it, not because Malta doesn't deserve to exist, but Malta is a small island, and with small countries you can get statistical aberrations, okay? Do you think you can focus it? Oh, good idea, okay? This is not so good for the video, and from here to the right, you've got Slovenia, Cyprus, Estonia, Poland, Latvia, Lithuania, Greece, Spain, Portugal, etc., okay?
And how many participants were in each country?
1,200, which is the normal number it takes. Well, 1,000 to 1,200 is the normal number it takes to get a representative sample of the population as a whole, okay?
And it doesn't depend on the population of country?
No. If you're surveying the American population of 250, 300 million, whatever it is, you can get a nationally representative sample with 2,000 respondents. This is another subject. I'll come back and talk about this if you like, but it's an interesting subject. I know it, and I understand why you're asking the question, and you. But if you give everybody in the population within certain categories of age, gender, socioeconomic group, an equal chance of being included, then there's no point in going from 2,000 to 3,000 to 4,000 because you simply get repetition. Okay? Now, this is well tried and tested methodology. Okay? But what I want you just to observe something is what's the characteristic of the countries to the left, and what's the geographic characteristic of the countries to the right? North and west, south and east. Yeah? So immediately that raises a question. What is it that links these countries and what is it that links these countries? And interestingly, although all of the founding members of the European Union are in this group, there's one missing. So France, Germany, Belgium, Netherlands, Luxembourg, and one other. The first 6 countries in the European Community. No, joined later. Italy. And Italy is here in another cluster of countries. Okay? So what I'm really drawing your attention to is that you can, from this kind of information, start to think about how science and public relates in different ways in different cultures. I'm not making a normative, I'm not making an evaluative statement, I'm merely making an observation of, well, actually an observation of fact. Okay? But we really want to move on. But actually, answering questions in an opinion poll is a kind of participation as well. And if, for example, there's a local dispute over a polluting factory, and there's a campaign around it, or there's a university that wants to find out what people think about it, one way in which the people participate is by answering questions in an opinion poll. And that's a very often a good start for getting involved in different ways. But, we have all sorts of kinds of public campaigns around on science, for science, with science, right across the world. Here's students in Taiwan saying, something like, science is great fun. Here's something that exists in many, many countries around the world, a science week. We just had our National Science Week in Ireland. It's a very common concept. It tends to be lectures, talks, and so on. But from those very basic approaches, very basic models, other ones have emerged, and you've probably discussed them a bit now with both Andrea and Alex. And I'm not going to spend too much time on it except to come really to the question that's the question for tonight. A question for tonight. How different are these dialogue practices from traditional ones of popularization, which is regarded as hierarchical, top-down, linear. How different are these dialogue practices if the sponsors of the communication remain in control? Yeah, so if a university sets up an outreach office and as part of an outreach office includes questions and a talk with questions and answers, have they changed the relationship by having questions and answers at the end? Not necessarily. It's still a form of linear communication. But this is really intended as a rhetorical question for you to think about. When people talk about the shift to dialogue, as they do, they may very well be overstating the difference between what was done yesterday and what's being done today. So you keep your critical hats on when you look at these things that are called dialogue practices. But we'll take that a step further in a moment. Science festivals are a little bit different from science weeks. Science weeks tend very often to be based on scientific institutions doing in a less formal way what they do normally and in a more open and public way. Science festivals go onto the streets and allow people to participate in more diverse and possibly more rich and deeper ways. And as you will see in the case of the one at the top there, the Fiesta de las Ciencias y las Humanidades, you're now getting cross-disciplinary, interdisciplinary. Why are you laughing?
Spanish pronunciation, sorry.
It's like humanities.
It was okay, wasn't it?
No, it's, yes, it was good. It's not reassuring to
Okay. All right, well, I'll talk to you about that later on. Okay. Okay, I'll speak French then. Fête de la science. Le système solaire. And these are involving scientists and other disciplines. So you get a different kind of communication. You get the possibility for the public to be in a place where social scientists and natural scientists are communicating with each other and sharing their doubts and their lack of knowledge as much as they're communicating or disseminating their own knowledge. That changes the relationship, okay? And that's what we talk about when we're talking about participation. I prefer, this is my model of models. Don't try and take it all in now, but it has been quite widely used. Andrea has used a version of this as well, and he may have shown it to you in 3 columns as well. But in these different models, I explain them or try to describe them in terms of what's in the scientist or the scientific institution's head as they face the public. So on the last column there, from they are hostile to they are ignorant to we see their needs, they talk back, they and we work together. Yeah? So I'm making a clear distinction. Well, clear is overstating it, but I'm making a distinction between dialogue as two-way and participation as multi-way. Okay? So not just talking back, but actually being involved in deciding what we even talk about in the first instance, and having the possibility to interpret and to be critical of what the scientists have to offer. In lots of ways, the relationships are changing, not just because of the emergence of the science communication movement, if that's what we could call it, but also because of the expectations of funders and policymakers that scientists and research institutions and universities and technical institutes and so on will engage in some way with the public. It's even written into contracts now between the European Commission and researchers including researchers in planetary science, for example, because I've just been asked to join a committee of a European planetary science project, which has been given, I think, 10 million euro for a certain number of years, I don't know, 4 years probably. And of that 10 million, 800,000 goes to communication. You can do a lot of communication with 800,000 euro. Yeah? You could build at least 1 square meter of your big science center. No, you could do a lot with 800,000, and we will do a lot with 800,000. But that was actually built into the contract. Yeah? So that changes, again, how science meets the public and the public meets science. Again, you'll have this in the slides. And experts often step outside the expert community to be a part of a citizen community, just as citizens step in from the citizen community to be part of at least a research project in ways that I'll describe just now. And in some cases, we have seen that particular groups within the public have the capacity, which has been described as lay expertise. You understand the term lay? The laity are the opposite of the priests in the church. Yeah? So you have the laicos, and my Spanish is okay. You have the clerigos and the laicos, and you have, I'm sure, the same in Orthodox tradition, you know, the priests and the laity, of the ordinary people. Okay? And so you had experts and lay people. Scientific experts and lay people. And so it is again turning around these things when you come up with the notion of lay expertise. It's almost a contradiction in terms. Yeah, it's like a lay priest. Well, actually, lay priests do exist in some churches. Members of the congregation have certain rights to preach, so they become lay priests. Or lay preachers, perhaps, is the right phrase. A very strong example comes from the United States, and it's been seen and observed elsewhere, where the community of those people who are most immediately affected by AIDS in the 1980s into the 1990s knew, in some cases, more than the experts about how the disease takes hold and so on. And they became active as groups of concerned and interested citizens who were patients in the medical sense, and became involved in research projects in redefining where the research was going and so on. But there are other cases. And so science and public are now connected in many, many, many different ways, and these are just some. Are you familiar with the concept of public scientists?
Citizen science.
Well, citizen science comes in a different way. Public scientists are scientists who are visible, actually like the guy sitting beside you in the cafe to whom you try to explain ppm, or E equals mc squared. He knows that there is a nuclear physicist called X, or a biomedical scientist called Y, because they've been on the television, they're in the newspapers, they're writing in the magazines, they're interviewed in Hello magazine as a celebrity or whatever, okay? There are public scientists in every country. There are at least some, and in some countries there are many, many of these who are recognizable figures. There's various forms of public engagement, and you may have spoken about upstream public engagement, which is the kind of thing I was just referring to there, where members of the public get involved before the work is completely done and the results are delivered, and then the applications arising from the results are delivered. They get involved upstream in the sense that they get involved in thinking about, actually, is that something we really want? And it was very interesting to see one reaction to the debates and in more than debates, I mean violent clashes in some cases over GM foods and crops in Europe, Western Europe in the 80s and 90s, was when nanotechnology came along to say, come and talk to us. Yeah, and I was part of a discussion with the state agencies in Ireland that were involved in this, and with some of the researchers that were involved in this, saying, they actually were saying, we do not want to repeat the disaster of GM crops. Yeah, so they were allowing for the possibility, at least, that there could be engagement by the public further back in the process, and not just when they've produced aerosols and tennis rackets and clothing and windows for offices and so on, all with nanoparticles in them, and then saying, oh, maybe we hadn't thought about the possible risks, you know, to public health and so on. So that shift, even in that short period, was interesting to see. Excuse me. But one way, if you were to look at those countries on that graph there a moment ago, in terms of science in public discourse, you might be able to see also a difference between the countries to the left of the average and to the right of the average. You know, in France, in Paris, let's say, walking around the streets of Paris, actually walking around the streets of St. Petersburg, come to think of it, you see statues of scientists, you see streets named after scientists, you see university buildings named after scientists. You have a beautiful statue of Andrei Sakharov, although he's there for other reasons as well, I understand, just down the street here. So in that sense, scientists are visible in some way in public culture and public art. In other countries like my own, I don't think there's a single street named after a scientist. I'm pretty sure there's no public statue of a scientist anywhere. But we've had commemorative stamps with scientists on them. And that's another way too. We've had a Nobel Prize winner who's a physicist on a stamp. And science in my country is more or less absent from public spaces. Science is present in public spaces in many other ways, in many other countries. And scientists are involved in public controversies, certainly in Ireland, and certainly, I'm sure, in your country and elsewhere. Many controversies that are probably not just about what science is doing, but also some downstream applications of science. One of the current active ones in Ireland currently has to do with something called fracking. You're familiar with fracking? Yeah. It's probably going on in Russia, is it? I mean, there's a lot of fossil fuel extraction. You know, fracking involves extracting fossil fuels by pumping water at very, very high levels of pressure into the cracks in the rock that drives out or flushes out.
Actually, I think we don't resort to fracking because we have lots of
other sources.
Yeah, other sources of gas.
Yeah. And fracking, I suppose, has become a solution to another problem in the United States and Canada, where they've run out of, you know, sources that they can mine in the traditional ways, or they face environmental restrictions on traditional open cast mining and so on. However, hydraulic fracturing, which is its proper title, is very controversial in Canada, and it's very controversial in Ireland, where it hasn't yet started, but there is some exploration going on. So public groups are active on a question that arises from an application of science and an application of technology. And scientists are involved in those public controversies, sometimes on one side, sometimes on another side, and sometimes on both sides. This institution is an interesting one, and Dimitri mentioned it in conversation with me earlier. This is the Science Gallery in Trinity College in Dublin. And I draw your attention to it because it's in Dublin, because it contradicts everything I've just said. I said science is not visible in public places, it's not talked about in public discourse very much. Some controversies go on in which people are involved in GM foods and nano and hydraulic fracturing are are examples, but they're very local. And here we have in a university in the city centre of Dublin a gallery that faces onto the street saying, come in and explore science in new cultural contexts, in critical ways. Science Gallery's model, or Science Gallery's motto is where science and art collide. Yeah, collide, okay? But a collision is something that scientists are very interested in, for instance, in particle physics. High energy collisions are the basis of the research that's done in CERN, for example, and in other places. And this has been extremely successful. I mean, I'm not just selling you something because there's no need to sell it to you, you're not there. It's been extremely successful by any standards in drawing in a public that might not have been drawn into more traditional forms of science engagement, but also in developing a model that's new for science centres, and I hope Petersburg will have a look at this. It has no permanent exhibits. It has open spaces. Now, for a big national centre and so on, you couldn't do that. You have to have something that you know is reliably there so your school groups can come and so on. But what they do is they do an exhibition. This one was called, you can just about see it, Human Plus. It's the idea of the post-human future, you know, through genetic engineering and other forms of bioengineering. We have possibilities of new humanoid forms, if such a word exists. But it's also been successful in, as I say, in exporting this model to other places. So Science Gallery London will open next year. Science Gallery Melbourne is to open shortly. Science Gallery Barcelona will open. I believe there's conversations going on with the university in Moscow, but I will tell you who it is when I find out, okay? You might, yeah. I'd say it's a very early conversation that they're having. But so what I'm telling you here is that in my country you get contradictions, and you get them in every country. You get very traditional forms of communication side by side with very inactive publics, by and large, alongside very active publics that are minority, highly attentive, highly interested publics, yeah, and very novel forms of engagement. So it isn't a simple north and west of Europe do one thing, south and east of Europe do another thing. Or North America and Western Europe do one thing and the southern hemisphere does another thing. There are very advanced things going on in many parts of Asia and Latin America, for example. And this happens to be Africa. And this is a picture of a science cafe. Doesn't look like a science cafe? What does a science cafe look like? A science cafe can look like anything you can imagine it to be. There is no correct answer to the question, what does a science cafe look like? It doesn't have to be in a cafe. It doesn't have to be in a pub, although they often are. Yeah? I see you have a few Irish pubs here. You could try it in an Irish pub. A science cafe is an open meeting of scientists and members of the public around a given topic. Typically, the scientists get a few minutes to say what their perspective is on the topic, and then it's straight into questions and answers and discussion and so on. And this is an interesting one. It was women talking about health issues, including sexual health issues, in the only safe place that they knew they could talk about it, which was a church. Yeah? So, I say the globe, you know, is very diverse. I mean, what's going on in the global communication, in the global science communication field is very diverse, and there is no reason for each country to repeat what every supposedly more advanced country has done. I hear again and again in my capacity as somebody involved in the global network, people from countries where apparently less is going on in this area. Oh, we're very backward and nothing's happening and so on. And then I explore a bit further and find actually that's not the case. You know, I don't know that the person from Uganda who was talking to me even knew that this was going on. Yeah? Because it's not very, you know, you don't write big headline stories about something like this. This is local participation, but it's actually high level participation in terms of what people can do talking to, in this case, medical scientists or talking about medical science subjects. So continuing the listing of all the many ways, and sorry, not all, but in the many ways in which science and public are connected, I'll focus maybe on one there in the first point, consensus conferences. This is particularly associated with Denmark, where the Danish state, through its Board of Technology, recruited, again using the same kind of techniques as we referred to earlier on to do with surveys, recruiting people representing citizens in general, asked to sit in on a set of presentations about a controversial topic, make their own report on it, discuss it among each other, and then produce a consensus report at the end of perhaps 3 or 4 months of this. Yeah? Have you heard of something like this before? Denmark has a long tradition of high levels of civic participation. And that explains, at least as much as anything in the way in which they do science, why Denmark, on that graph that I showed you, on that diagram I showed you, was at that end. It's not only to do with science and how science sits into the general culture, it has to do with how citizens interact in general with each other and with the authorities and with the powers. And science, in a way, is a kind of authority and a power. Did Fred, who's from the Netherlands, mention science shops at all? It's a particularly Dutch thing, but not exclusively. But as I've mentioned Denmark, I'll mention Netherlands. This idea of a science shop is that a university opens a shop, at least metaphorically, a place onto the street, which says, citizens, have you got a problem that you want us to research? And people walk in the door and say, we've got a polluting factory, or we've got a high cluster of cancers in our area, we want to know why it is, or we've got noise from the airport and we wanted to understand how it's affecting people's sleep or whatever. And the university then tries to find people to work with them. Yeah? That's the concept of a science shop. Now, it's being spread across Europe and beyond. It's called something else in North America. It's called community-based research. The model is basically the same. This is upstream engagement long before the term upstream engagement was even thought of. Yeah? And it's been happening in the Netherlands for 20 or more years. More recently in other places. Citizen science, which Dimitri just mentioned there, looks similar, but it's a slightly different kind of model. Rather than a single group of citizens asking for a job to be done on their behalf, it is scientists asking citizens to join in a project where they may act as data collectors, for example. Okay? At a very low level, people get asked in Ireland by an organisation called Bird Watch Ireland, you know, to fill in a sheet I've seen a hawk, I've seen a pigeon, I've seen a dove, I've seen a goldfinch, I've seen a sparrow, and so on. You know, and so when all of this is added together, it becomes usable scientific data on species increasing or decreasing, moving or not moving, and so on. But citizen science could also be amateur astronomers. And I'm pretty sure that I know that there are planets named after amateur astronomers from Russia. I'm fairly sure there's comets named after people who are amateur astronomers who've just made observations that professionals haven't done. And so in a sense, they're kind of like citizen scientists. They happen to be doing it in their back garden or in a shed at the bottom of their garden with a telescope out the roof. Yeah? But they are citizen scientists. And then there's other kinds of citizen science which involve citizens also in discussing what question is going to get asked. That's probably, if you were to arrange different kinds of participation, public participation in science on a ladder, you'd probably say that, you know, some forms of citizen science are somewhere near the top of that ladder in terms of the possible influence members of the public might have on the outcomes. Yeah? Whereas taking part in collecting of data on birds in your garden might be somewhere well down the ladder, and then being involved in a consultation or dialogue further down the ladder, and so on. Okay? But these are different kinds of practices, and these are different kinds of models, and various people are working on trying to arrange them in a way that, as a typology, it allows them to be accessed and used for making strategies by scientific institutions and indeed by citizen organizations. Not everybody wants to be involved. Nobody's required to be involved or obliged to be involved. And in any case, a lot of science will forever remain closed to the public for either military reasons or commercial reasons or for cognitive understanding kind of reasons. You know, this is not an agenda about making all science equally accessible, equally open to all members of the public. That kind of utopia just doesn't exist or make any sense. Just actually, I'll finish on just this last one. Do you know what open science is? One thing that's been happening through all of this development of the science communication field is that the technologies of communication have been changing as well. Yeah? And it's interesting that the year that we started developing a Master's in Science Communication in Dublin was the year I first saw the World Wide Web. Yeah? And it became public, it became open for public use about the mid-90s, at the same time as science communication was on a rising curve of expansion, both in the universities and in the field of practice. And open science is like citizen science to the power of 2 using the internet, where all the data is available. And there are projects, you can check this out, you can check out science cafes on the internet. There's a website devoted to science cafes. You can find them all over the world. You can check out citizen science on the internet, and you'll find lots and lots of projects going on all in many different parts of the world. And you can check open science on the internet, and you'll find examples of projects going on in many parts of the world, although less of them at this stage. And their characteristic is that the questions, the methods, the data are all made public on the internet. And of course also the reports and the outcome, the papers and so on. Why would anybody want to be involved in something like that? Because they think that maybe the development of this particular application is possible out of that particular research, and that might have some implication for them as a person with this disease or with that need or with that particular interest or whatever. So we have a range of these practices, and we have a possibility and possibly a need even to put these in order to make the distinctions clearer. I'll finish with this one. There's another one of those Eurobarometer questions, and it divides Europe slightly differently. The question is, what is the level of involvement citizens should have when it comes to decisions made about science and technology? And then people were asked to agree with the statement, or disagree with the statement, public dialogue is required. Okay, you understand required? Yeah. It's not quite as strong as saying necessary, but it's close. Yeah? And the dark blue countries have the highest level of agreement with that. The middle blue countries have the next level of agreement, and the light blue, almost turquoise ones have the lowest level of agreement. So there is a sort of north, west, south, east, but it's slightly different. So France is in a group with Portugal and Spain and Greece. Ireland is in a group with Poland, Lithuania, Latvia, Romania, Bulgaria. Yeah? So when it comes to involvement and participation, the answers are not distributed in the same way as they are when it comes to interest or feeling informed. As I say, it's messy and it's diverse, and that's why it's such fun to do. So thank you.
So we have some time for questions. I'll ask the first question, because I have the privilege. The first question is, do you think there is for countries where science communication is underdeveloped overall, do you think there is a shortcut, especially if we talk about the evolution of science communication in terms of the evolution of models, like from the deficit model to the responsibility model? Is there a shortcut? Can we just skip all these other models and just go directly to the one that you're actually using right now?
Short answer is yes. That's what I meant by saying you know, each country does not have to reproduce the history of each other country, but it has to be done in an appropriate context and an appropriate way. I think you can take the criticism of the deficit model as a given. However, in the paper that I did that has that table in it, I say this is not an evolution. It is an addition of different opportunities and possibilities. And there may be very good reasons for downgrading the dissemination or popularization deficit model, but it may still have its place in certain circumstances. And what you've got to do is get smart. And I suppose this is a kind of the longer answer to your question, is yes, get smart about what the possibilities are. Recognize that there is a range of possibilities, and then try and get people involved in thinking about what is appropriate in this country, in these conditions, on this question. But it may be different in the same country, in the same conditions, on a different question, or it may be different in the same country, on the same question, in different conditions. You know, you've got to figure out what's right for the moment and the situation. So I don't think there's I can't give you a recipe, you know. Here are, this is the way to do it. You can jump 2 stages, because I don't believe in stages. I think you may have seen a report that was done under a European project called MASIS, yeah. And they use, because I heard you use a term that's used there, they use this idea of a consolidated science communication infrastructure. And although I was part of that project and I did the Ireland report, I think that the use of the terminology fragile, developing and consolidated implies an evolution. And that sooner or later, all of the pink countries, the light blue countries will become middle blue countries, and then the middle blue countries will become dark blue countries, and the dark blue countries will go off the edge of the globe. I don't know what will happen to them. But it doesn't happen necessarily like that. Because there may be dark blue spots all over that map, where things are happening at local level that are very, very highly sophisticated and advanced. Yeah? And thinking only in country terms. Well, what I think I'm saying to you is you guys have the possibility of doing something in this fantastic city which, for the moment, doesn't take account of every other part of the Russian Federation. But you focus on what you can do in this, the most open of all the, historically, of all the Russian cities, probably. Looking to the outside world, I mean, being on the Baltic, etc. And with, good neighbours, with lots to tell you. In Finland, starting up things in Estonia, interesting things going on in Sweden, not so much in Poland, but so on. So yes, I think you can not so exactly jump stages, but I think you can innovate without feeling you have to go back and reinvent the wheel. If that makes sense, yeah?
Questions?
Can I ask you a question? On a scale of 1 to 10, yeah, not how much did you agree with me, how much did you understand? And so was it 5? Up or down from 5? Did you understand?
What's the scale again?
1 to 10. Okay, where 1 means I didn't understand a thing, yeah, and 10 means I understand absolutely everything, yeah. I want to get a sense of whether, you were able to understand this. Okay, so is 5 too low or 5 too high? 4? 3? No? Go up? What? 8 to 9, good. Yeah? 8, okay. Yeah? 7? Yeah? Okay.
So what are your questions then?
So exactly, that's exactly, yeah. Yeah.
Can I then make a comment and then a question then?
Yeah.
Just the comment that is that, do you know that scientific literacy studies are still conducted in Russia and they are modeled on the Eurobarometer? They ask you the same questions.
Yeah.
So I don't know what's the reason they're doing this, but they always hit the news. 87% of Russians think that it's unreal, whatever.
They do the literacy surveys.
Yes.
Do they do the questions about how informed or interested are you? Yeah, also.
They had modeled the whole poll on Eurobarometer a few years ago, when Eurobarometer was still doing scientific literacy studies. Yeah. So, as Eurobarometer is evolving further and further, the Russian group stays where they began.
Yeah.
They keep doing the same thing.
And are they part of a university or a state agency?
Part of the university. It's
okay.
An institute which belongs to a very big university in Moscow.
And when they publish those findings, what story are they saying? Russia is in a good situation or a not so good situation. What do they tend to?
I don't remember exactly.
Yeah.
But they're used to carry a story with it. To interpret somehow the results. So that was the comment, and the question is, would you say that despite all the efforts in science communication that Europe is doing, the trust in science and technology is still declining? I think that one of the recent Eurobarometers, there was a question about that, and the public said that the trust is getting lower because science is increasingly dependent on money from industry and business. What does it sound like that?
Yeah, I don't remember what the survey showed. So
more than 50% thought that their trust was declining because of that.
Yeah. I think that the trust problem is hugely overstated, and it cannot be looked at in isolation. So, and that's why I said earlier on, it's a difficult thing to research. But you need to consider trust in scientists in the context of trust in other professions and other public authorities and so on. Okay? So I can tell you as a former journalist that what the surveys in Western Europe show is that trust in journalists is way down at it's off the scale low, okay? But people still watch television news every night. So do they sit down to watch the television news saying, I don't trust any of this? No. You wouldn't. You would not put yourself in that position that every time you turned on the television news, you were going to be told lies. Well, you might. But that's a form of masochism, yeah? But so these surveys, first of all, I think you have to put them into context. So what levels of trust do people show as distinct from what they say in various positions of authority, yeah? Priests of the Orthodox Church, members of the Communist Party, politicians at national level, you know. Well, I'm not showing you the hierarchy. I'm indicating that you have to put these things in context. And do you know what? When you do that, scientists come out very high. When you then ask them a question about their involvement with private enterprise, you've already given them an answer. Do you see what I mean? Because most people thinking about scientists would not think automatically, spontaneously is the word we use in this field, would think spontaneously, oh, all of those scientists are only doing what Intel, Microsoft and IBM asked them to do. Yeah? I imagine Intel, Microsoft and IBM are sponsoring research here. You know, if they're not doing, they should be. Because you've got all, exactly. You've got all of these brilliant programmers, of course they're doing it. But walk out into the street and say to people, you know, that these are the most brilliant programmers in the world, in here, in this place, and I'd say, fantastic, and we trust it. And then if you were to tell them that there's private research, private money coming in, they might have some questions and so on. But you see what I'm saying? The question already contains an implicit answer. And I think you have to develop methods of listening to what people are talking about that are much more subtle before we make statements that trust is going down or trust is going up or trust is affected by this, that, or one factor. It's very much more complicated. We need, as well as the sort of stuff that's going on here, we need qualitative research on a very large scale, which involves sitting with people, hearing their concerns, letting them talk about things, see what comes up spontaneously, and so on. Yeah. If private enterprise involvement in scientific research was a reason for scientists to be distrusted, well then trust in scientists in the United States should have blown up 50 years ago. Should have been impossible, but it's not the case.
But, sorry, it's just a comment, but it seems to me that it's not only the problem of trust. It seems to me that it's much more important for our country maybe, or for our public, is the point that it might be possible to feel yourself just a part of this big dialogue, a part of this public that may have any access to the scientific results or some scientists or so on, because as it seems to be that in Russia now we have no such wide and open access to these scientific results or just science as a whole. And it's not the question of trust only. But first step and first big step for us is just to feel yourself in this circle of communication, in this circle of opinions of these dialogues. It is just the first point. And the second point that seems to be very important is just that you are the first in our auditorium who speaks about this conversation and this dialogue between social science and natural science. It's one of the main points from my point of view, because I'm the person who work in the humanitarian sphere, in the sphere of social science. I'm working at the museum. So, and it's for me, it's one of the most important points that it might be possible to construct any dialogue and a bridge between social science and natural science, mathematics, computer science, and technologies, and so on. Because this bridge, this connection, this link is just the place for people, for the public. Because public is between these two different points or different sides. And from my side, these two positions, I mean, this democracy in open access to scientific results, and the second point is to real open dialogue between different types of science, so to speak.
Thank you. I couldn't say it better. Thank you very much.
It's just not the question, but the comment.
No, I understand. I understand.
Just for me, during your lecture, for me it was one of the main points that have to be our first steps. Because the question of trust is very difficult question. It's not just a question of trust in science. It's just a global question of trust, because now we are living in the sphere of media.
Yeah.
And these media try to produce more and more information every second. And this is the question of trust. It's not only the problem in science.
Very good, thank you. What you said relates to something I was saying to Dmitry before the lecture. Why, he asked me for a couple of arguments, why is it a good thing to consider putting a master's in science communication together? And my first answer, I think, or my second answer, was because it's a great experience to have within the university, communicating across the disciplinary boundaries. But let me tell you a little story which brings together two elements of what we've spoken about here, maybe even three. A science cafe experience. It doesn't quite relate to what you've just spoken about, but it does, it's close enough, I think, to what you were saying about trust. A science cafe experience in that science gallery that I showed you, early in the pandemic of swine flu. Swine is pigs, yeah? And do you remember that? It was about 6 years ago, maybe 5 or 6 years ago. So there was the bird flu that came from Asia, and then there was the pig flu that came from Mexico, apparently. Okay? At least that was the story. It's always somebody else, you know. You know, the Chinese and their hens, and the Mexicans and their pigs. Anyway, so in the science gallery at lunchtime, in an open cafe area with people having their soup and the noise going on and so on, 3 scientists, an immunologist, a virologist, and I think a doctor, or a medical educator. Said, what do we know about this? And why should we be worried about it? And what should we do about it? And so on and so on. And as the discussion went on, it became clear that there were things, important things, that the researchers, not just the researchers present, but the researchers who were working on trying to analyze this particular virus, didn't know. And so we had people in a position of authority, apparently. They were standing, we were sitting. So, sorry. They were standing, we were sitting, and they're saying, we don't know. And that changes the relationship. But you know what? It probably increases the trust. You're much more likely, are you not? Sorry. To trust somebody who says, this is what I know with reasonable certainty, this is what I know with less certainty, and this is what I don't know. Than somebody who stands up and says, this is what I know, 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 and this is what you need to know. Yeah? Which is the traditional form of communication. So, I think there's a relationship between openness, as in being open to say there are things I don't know, and trust. Now, how do you research that? You can't do that by asking people a set of questions. You know, in the style of these surveys. That's where the interesting stuff is going on, and that's where the difficult research is, and that's where social science comes into it. I mean, there are social scientists designing these surveys who really ought to be retired, you know, because they have been repeating this stuff, and because they love the fact that they've got 30 years of data, you know, which is comparable across time, and that's quite interesting in itself. But they haven't really reflected properly, fully, on what may be implied in the questions that influences the answers, which is really basic. If you know this, if you have background in social sciences, you know, when you're asking a question in a survey, you have to be, first of all, clear, it's unambiguous, and it in no way leads the respondent to one answer rather than the other. Now that's very difficult to do. Even involved is a leading word. What's the level of involvement citizens should have? It's very hard to say no involvement at all. Once the question's been asked, it's been put into your mind, oh, maybe citizens should be involved, you're not going to say none at all. So actually, 0 to 50% is a huge range for the light colors. So how low does it go? How near to 0 does it go? You know, of course it doesn't go anywhere near 0, because nobody's going to say, no, I don't think citizens should have any involvement. Maybe some scientists might say it, actually. And in any representative sample of the population, there might be 10 scientists. So maybe there's 3 scientists out of those 10 who say citizens should have no involvement. Yeah. But you know what I'm saying. Informed, again, it's very hard to say, I don't feel informed at all. I'm not at all interested. By the way, the highest level of don't know responses on many of these surveys, and don't know, as you'll understand for a reason from the anecdote I just told you, I think don't know responses are really, really interesting. The highest level of don't know responses comes in many cases from Ireland. And I should know why this is, and I don't know why this is. I don't know why they don't know.
Is this something Irish?
Well, it's interesting to look at the pattern because, and I spoke to a colleague about this who should know, the lowest level of don't know responses in the relevant ones that I was looking at came from Greece.
They know everything.
Exactly, they invented civilization, didn't they? Yeah. So of course they know. No, there must be something about admitting to not know. But there are at least 3 different kinds of don't know. I don't know, but I'd like to know. I don't know, and it doesn't matter to me. And I don't know why you're asking me this question. And there's a few other ones as well, you know.
All right, so more questions?
I want to ask one question. So some research is really interesting for most of the people. Everything about flu, about AIDS, about genetically modified organisms, and it's not very difficult to make communication about these topics. But some research really looks very fundamental, too fundamental,
Yeah.
so probably it looks like nobody interested. So what do you think? If we need to try to make it public, or we just need to divide? Some research is for everyone, it's for people it's interesting, and some research is just for scientists, so don't think about it.
It's a really interesting question. Does this relate to your own work?
Yes.
Theoretical physics, no?
I'm a biologist, but now I work in a school tech. Maybe you know this new...
You work in a... Sorry, you work...
School tech. It's
Did you
university in Moscow.
know Qualcomm initiative? Right, so there's a huge innovation center that was established years ago, and they have a university. So it's a modern university, and they're investing in science communication part. We have a specialist on there.
Good.
Yeah, and now I'm making press releases and try to make science public, and sometimes I just think anyone need it, or it's just fundamental.
Okay. Well, maybe I understand the question, and I'm sure everybody understands that that's a difficult problem to deal with. There may be some, in fact, the vast majority of material published in the scientific journals is not that interesting, even to scientists. This is true. You know this. Most papers get no more than 2 citations, you know, and many papers never get a citation. Anyway, so you've got a lot of scientific material being published that's not even of interest to scientists. And there's a lot more information, scientific information that's been published that's of considerable interest to the public, particularly in the areas of biology, you know, where it becomes medicine, where it becomes biotechnology, you know, where it becomes pharmacology and so on. And then there's a lot of other stuff that's possibly of interest in scientific terms, but not great interest in public terms. So somewhere you're working in this space, yeah. Even if you don't seek to make accessible every single individual paper that's published, you probably have some responsibility, at least to the taxpayers, if you're a public institution, to say what it is you do in general terms and why it's worth doing. So maybe it's a different kind of story. It's not a story about a particular piece of research, it's a story about, you know, this is why we do theoretical physics. This is what, I don't know why they do theoretical physics. No, this is why they do theoretical physics. This is why they're doing, you know, mathematics. This is why they're doing, you know, basic biochemistry or whatever. And the answers may be more difficult to put into popular terms, but they may be to do with building capacity. It's maybe to do with asking fundamental questions, which in turn may lead to other kinds of questions that have more direct application. Actually, look at the stories that CERN was able to make out of, you know, particle physics. They found the Higgs boson. So what exactly does that mean in popular terms? Not that clear what it means, yeah? So they confirmed the Standard Model. What does that mean in popular terms, yeah? And what they managed to do was to tell a story about a man, little man now retired in Scotland, you know, who wrote a paper in 1965 making a theory that this thing probably exists and this thing needs to exist if the whole thing is going to hold together, and they put his name on it, and then they spent millions and millions and millions and millions and then more millions and then more millions doing research in order to prove that it actually does exist. And so it becomes a story about him, and it becomes a story about the institution, and it becomes a story about a history of research, and so on. It makes no difference whatsoever to my life that the Higgs boson has been confirmed, or yours, or yours, or yours, or yours, or yours. It makes a lot of difference to the way physics is done, and so on. I had the occasion, I'm sorry to tell a story about another story about a science cafe, but it's a story I like telling. I've done science cafes where I'm the person who's asking the questions and getting the public involved and so on. So there's 4 of us in a cafeteria in CERN, okay? 3 CERN researchers and myself sitting on high stools. They don't have notes, they don't have slides. They just talk a bit about their work and so on. And then people get involved and start interrupt them and ask questions and so on. And I said to the 3 of them, I said, this was the year 2001, okay, 14 years ago, nearly 15 years ago. I said, what happens if you don't find the Higgs boson? And there's a pause, and then one of them says, but we will. Yeah, and they agree, yeah, they will. I said, no, that's not, my question is, what would happen if you don't find proof of the existence of the Higgs boson? But we will. And I tried it 3 times in different ways, 4 times in different ways, and eventually said, we'll go on doing it until we do find it. That's how science really works, yeah? Not like the idealized science. They just keep on because you're so convinced that the model actually is correct, you'll spend millions proving it's, So it's a different kind of story, yeah? And it's a story about the equipment, and it's a story about the personalities, and it's a story about the history, and it's a narrative. And that's maybe another way to approach it. Not everything that comes out of the machine is a perfectly formed sausage that you can then, put onto the plate,
All right, I'm really afraid that we have to stop somewhere because
You have to play a game.
yeah, we have this.
This
Thank you, Brian.
damn water. Yeah.